Hey grade 10s, it's Mrs. Friesen. I'm just going to do our last lesson out of Unit 6 today. Just a couple quick notes. If any of you have already watched the Unit 7 videos, you will see that my stylus will work much less well than the one that we used in the Unit 7 notes because Mr. Thide has a fancy stylus and I'm working on getting a better one, so I apologize for that, but we're going to make do with what we can. Also, make sure you keep updating on Teams, checking in on what I'm saying for our assessments for this unit because I will be uploading them very soon now since we are going to be finished the unit as of this video. Okay, so let's start talking about today's topic. So we're going to talk about distance between 2 points, the midpoint of points, and then degree of some functions. Now, distance and midpoint are very related topics, and degree is kind of on its own, but I needed to put it somewhere, and it wasn't a full lesson, so we just are going to lump it in here. All right, so we are going to start actually with midpoint, even though I wrote distance first. That's fine. We're going to look at midpoint first. And so we can see here, using the definition that's given, that the midpoint is the center point on the line. Okay, so we know then that means it's exactly in the middle between any two other points. And we're going to look at this graph below here and start talking about that. So let's first start with finding the coordinates of the 2 points, and then we're going to go from there. So if I look at this left coordinate down here, kind of at near the bottom of the positive y area, if that makes any sense, that leftmost coordinate that I've given you, can see that just by counting using the scale on the axis that I have a point -5, 1. And then looking at the second point, the top point on the graph there, again, just by counting using the scale on the axis, I can see that I have the point 3, 7. Okay, so let's start by thinking about what is the midpoint, right? So which point would be exactly in the middle between these 2 points? So if I were to draw a line, oh boy, there we go, between the 2 points, where would that middle point be? That's what I'm asking. So that's what we're going to figure out today. So let's take a look here. So if you think about the midpoint, when you want to find something that's exactly in the middle between two things, you can take the average of those two things, right? So if I wanted to find what's between 0 and 10, I can just take the average of 0 and 10. So 0 plus 10 divided by 2 is 5. And that's how we found the middle, right? And so the midpoint on a graph is exactly the same. So we're going to find the midpoint by taking the average of these 2 points. Okay. Now, keep in mind, though, that we do have an x value and a y value in both points, of course, so we are going to need to find the average of the x and the average of the y. So let's take a look at x first. Okay. So I'm just going to add, again, those two values, those two x values, -5 and 3, and I'm going to divide it by 2 to find their average, right? So that gives me -1. And then for y, the same thing. I'm going to find the average by adding the two y values together and dividing by 2. So in this case, 4. Okay, and so that means that the midpoint is, that's how I often will represent midpoint, okay, just MDPT, midpoint, you know, is -1, 4. Okay, so we can put a box around that as our answer. So you can see what I mean about my stylus. It's not awesome, but if you can't read anything, just message me on Teams and we can talk about it. Okay, so if we think about the process that we just employed, finding the midpoint of the 2 points that we started with, these two that are on the graph, then we just took their average, right? So we are going to then find the midpoint formula by thinking about that. And so what I mean by that is that we can find the midpoint of any 2 points in general by first finding the average of the x values to find the new x value, just like we did here on the midpoint in the earlier example, and then following that by finding the midpoint of the y values, and that gives us our new y value, again, just like we did in the earlier example. So that's why that works, and that's what the formula is that we're going to be using to find the midpoint in a few examples on the next page. Okay, the other thing we're going to talk about is to find the distance between 2 points. So I'm going to take a look at the graph here. So if you can see here in the notes, it says we can imagine that the 2 points are ends of the hypotenuse of a right angled triangle. Okay, so we are going to then draw in the other 2 sides of the triangle, which are the, of course, horizontal and vertical legs. Okay, and so let's draw that in case some of you aren't totally sure what I mean yet. And then we are going to find the distance using that. So if this was the hypotenuse, sorry, again, bad stylus, and then there we go. Oh, shoot. One too long. Sorry, you guys. I'm going to try that again. Okay, there we go. So there's that one leg of the triangle. And then the other leg of the triangle is here, right? So I'm just drawing in those 2 legs, and then of course we would have a 90-degree angle here in the corner. So that's what I mean by we can imagine that the 2 points are the ends of the hypotenuse and the other 2 sides are the horizontal and vertical legs. Okay, so now we want to figure out how long the legs here and here are, right? Because if we think about our knowledge of Pythagorean theorem, then we can find the hypotenuse, right? So if we find this length here and then this length here, that will give us a squared and b squared, so that we can find c squared, which will lead us to c. So I'm going to scroll down here and we're going to write that in on our notes. So first thing we want to do is find the length of each leg. So we're just going to count, okay? So counting here, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I can see that this length is 8. And then same thing here, if I just count from the top here, the point all the way to the right angle, I can see that that is a 6 long. Okay, so then we can figure out the length of that hypotenuse using Pythagorean theorem. So let's do that here. I'm going to just take a different color though, so you guys can see it. Okay, so we have the knowledge that a squared plus b squared is equal to c squared, right? So in this case, that's 6 squared plus 8 squared is equal to c squared, right? So we are looking for that length between the 2 points. And again, just to recap, in case you weren't sure why, we're finding this distance, which is like the length of that line segment, right? So the distance between 2 points, and the way that we can do that is to use the Pythagorean theorem. So let's finish this off. Okay, so we know that 6 squared is 36 and 8 squared is 64. Oop, sorry. There we go. It's equal to c squared, so we can say that c squared is equal to 100. And then that means that c is equal to 10. Okay? And so because of that, then we can figure out that the distance between the 2 points is 10. Okay? And we usually will represent distance with d. Makes some sense. So d is equal to 10. All right. There we go. I'm just going to redraw this, make it a little bit neater. Can't believe how bad this stylus is. I'm sorry, you guys. School didn't have a better one for me in this kind of crazy time, so I'll get a new one soon. All right. So thinking about that, what we just did was we found that the distance is equal to c from Pythagorean theorem, right? And so we know that c squared is equal to a squared plus b squared. And that means then if I wanted to find just c, I could square root both sides, right? So in this case, c is equal to the square root of a squared plus b squared. Okay, and so that means that the distance is equal to that. Okay. Now, the next thing that I'm going to say, some of you aren't going to like, and I understand that, okay? So just bear with me and maybe reread it a couple times if you need to, or rewatch this part of the video. And if you're still confused, definitely chat with me on Teams. Okay, we're going to talk about A and B. Okay, so A and B are found by, if you take a look at the graph, the distance between the corner and the point in each case, right? The corner and the point find you the distance of A and B. And so essentially what we're doing is we're taking a look at what is the x value here and what is the x value here to find this horizontal distance. And we're taking a look at what is the y value here and what is the y value here to find the vertical distance. Okay, so that is what we're going to substitute in on our formula. Okay, so that means that C, which will eventually replace with D, right, because we know those are the same in this case. So we can say that A, again, that one leg of the formula, is the distance between the x values. And because A is squared, then we're going to keep that squared. And then B is the distance between the y values. And because B was squared, we're again going to keep that squared, remembering to always extend our root sign far enough to cover our whole formula. Okay, I'm going to make that a little bit clearer. Hang on 2 seconds. Okay, there we go. And then we can finish it off by saying that we already knew that D is equal to C. So we can say that the distance between the two is equal to this A squared plus B squared business, which we're just expressing in terms of A and B. I know that I kind of ran out of room there. Sorry about that, you guys. This stylus is so hard to work with. If you can't read that, let me know. But it's the same as this second to last step, except that I just said D instead of C. Okay, so now that we have the distance formula and the midpoint formula, we're going to use them to do some practice. Okay, so as usual, like I always say in class, if you don't understand all these explanations of why these formulas exist, that's okay. Okay, I'm giving that explanation to people who want it because there are some of you who prefer to understand. But if you don't care, that's fine. Okay, you can just use this formula and this formula even if you don't really know why they work, and maybe eventually it'll come to you and you might kind of glean some understanding the more you practice, so that's fine. Okay, I'm not going to ask you to explain to me why they work, just to use them. So let's do those examples now. Okay, so we can talk about the distance and the midpoint between each of these pairs because we have formulas for both of those. So let's start off with doing the distance. There we go. And midpoint of this first example. If you would prefer to do all the distances at the same time and then all the midpoints, that's up to you, but I'm going to go example by example, so finding the distance and the midpoint between each. Okay, let's start with distance, just because I said it first, and that's fine. Okay, so again, distance is equal to the big square root of all that stuff that we looked at here, but some of you, myself included actually, find the square root sign a little bit overwhelming when I am looking at that big gigantic formula. And so instead of doing just distance on its own, I'll sometimes just start with d squared and then square root everything at the end. So instead of having to do that huge thing, I'm just going to do this first. And then I'll square root everything at the end. Okay, so if that is easier for you, you are most welcome to do that. I'm just going to zoom in here a little bit so you guys, I have a little bit more room to write. Okay, so just because it's hard to work with this stylus. Okay, so we are going to plug everything in. Okay, if you like to label your points, you're most welcome to. You don't have to. I am always just going to use the second point as x2, y2, and the first point as x1, y1. I think I said that right. The first point as x1, y1, the second one is x2, y2. So if I said that differently, my apologies. That's what I mean. So the first point with the labels 1, and then the second point with the labels 2. Okay, then the y values, so same thing. Okay, so you can see I'm just plugging in x2, x1, y2, y1. Just like when we use the slope formula, and so on. Okay, so that gives us 13 minus 3 is 10 squared. Plus 24 minus 0 is 24 squared. Now those are both squares that you should, and hopefully, in theory, remember from our unit on powers and roots and all that stuff. So if you don't, you should refresh yourself. Okay, so that means that d squared is equal to 676, which gives us d is equal to 26 when I square root both sides. Okay, so I just square rooted both of these to get the answer on the last line there. Okay, and then the midpoint is a little bit more straightforward. I think people find the formula a little bit more doable, so let's do that one now. So the midpoint, as we looked at last page, is simply x1 plus x2 averaged, okay, and then y1 plus y2 averaged. Okay, so again, I'm just going to plug those in. First point, x1, y1, second point, x2, y2. That's it. Okay, so x1 is 3 and x2 is 13. And then y1 is 0 and y2 is 24. So that gives me a final answer of 16 divided by 2, which is 8. Normally I would write out an extra step, but as you can see, I'm totally out of space. And then 0 plus 24 is 24. Divided by 2 gives me 12. So there we go. Those are my 2 answers. There we go. Okay, so let's move on to the next example. I'm again going to zoom in to give myself maximum space. So write as small or as large as you need. Okay, what color this time? Hey, I like that pinky color. Let's try that. All right, so we're going to do the exact same thing. Okay, distance, and again, I am going to find d squared because I find that more doable and I make less mistakes. But if you want to just skip right to the square root, that's fine. Okay, you guys know that I don't have like weird rules about what order you have to do things in. Doesn't bother me. Okay, so we're gonna do x2 minus x1. Okay, so just like we did over here, right? x2 minus x1 plus y2 minus y1. Now, the important thing here, like always, is to make sure you're being consistent, right? So whatever point you do as 2, you should do both coordinates as the x2 and y2 and so on. So you don't do any mix and matching. Okay, so I'm gonna do -2 minus -8, right? So you can see that's my x2 subtracting my x1, okay? And then I have y2, which is -5, subtracting my y1, which is 3, okay? And I'm gonna... So that's -2 plus 8, okay? And this is -5 minus 3, right? That's -8. Okay. Well, I guess I should write that more consistently. Sorry, guys. Hang on. Okay. There we go. And so then -2 plus 8, of course, is 6 squared. And -5 minus 3 is -8 squared. Okay, really important here. Keep that negative inside the brackets, right? Because the whole thing is getting squared. And that means we're going to end up with 36 plus 64. Okay, so d squared is equal to 100. And that means, pardon me, when we square root both sides, that d is equal to 10. Okay, let's do the midpoint. Okay, so we have, again, we're going to add our x1 value, that's -8, plus our x2 value, -2, divided by 2 to average it. And then we're going to do the same thing with y. y1 is 3, plus y2, which is -5, divided by 2, okay, to average it. All right, so -8 plus -2 is -10. When I average that, we're going to get, -10 over 2. Okay, and then 3 plus -5 is -2 over 2. So that gives me a final point of -5, -1. Oops, there we go. Okay, so there's the midpoint. Again, just a reminder, like, what are we even doing with these? Remember that these are 2 points on a coordinate plane, and when we find their midpoint, we're saying what would be the point that's exactly in the middle between them, and when we find their distance, we're saying how far apart are they if we were to measure with a ruler, okay? How many units are they apart on the graph? All right, let's go down to the third example here. Okay, so 0, 4, and 6, 6. So I'm going to start with my distance again. Again, you can do this in either order. I don't care at all. Okay, so we're going to have d squared is equal to x2. So that's 6 there, right? minus x1, which is 0, all squared, plus y2, which is also 6, minus y1, which is 4, all squared. Okay, so you can see there that we're getting 36 plus 4, so 40. Okay, now you're going to notice that when we square root this, sometimes we get a square root that isn't perfect, right? 40 does not have a perfect square root. And so because of that, we're just going to simplify into lowest radical form, okay? So I just want to remind you that those skills that we gained in our radicals unit aren't over now, so to speak, okay? We do want to keep using those to always simplify to our lowest form. If you left your answer here, it would be E1, okay? So just a heads up on that. All right, and then let's use this purple. That's pretty. All right, so now we're going to find the midpoint, okay? I hope you are feeling very confident about this for becoming old hats, as I like to say, at this process. All right, so midpoint. Let's average those points, okay? So I'm going to have x1, 0, plus x2, 6, all averaged. And then the y coordinates, the same thing. Let's average them out, okay? Okay, if you need more steps in the middle, like I always say, that's fine, okay? But if you don't need more steps in the middle, that's also fine. Like, if you just showed this much work, that would be totally sufficient, okay? Now, I would like you guys to pause the video, okay? Like, actually pause it, and then try the last example, okay? So move over to this side of the page and try it out. See if you get them right, and then once you feel like you've given them a shot, then you can just play the video again and I will show you the process, okay? So go pause it. Do it now. Seriously. Okay, I hope you paused it and I hope you tried it. I would feel very proud of you if you did that. So good job if that's what you did. If you didn't, seriously, just go do it now, okay? Seriously. All right, distance. So we have x2, which is negative 5, minus x1, which is 3, all squared. I'm going to add that to y2, which is 1, minus y2, all squared. Okay. So then I have negative 8 all squared plus 1 minus negative 3 gives me positive 4 all squared. Okay, again, a reminder, very important to keep that negative inside the bracket, otherwise you're going to get the wrong answer. Okay, so then negative 8 squared is 64 plus 16, which is 4 squared, which gives me 80. So that means that d squared is 80. So when I square root both sides, then we can see that d is the square root of 80. Okay, same as last example, you don't always get a perfect number to square root, and so when that happens, you're going to reduce. So here I know that 80 is equal to 16 times 5. Okay, so that's what I'm using here to do the square root of 16, which is 4, and then leave the 5 under the radical. Okay, that's the final answer. Okay, and then let's do the midpoint. So we're going to average those values again, okay? I think you can see the pattern that we're doing here, right? So x1 plus x2 averaged, and then y1 plus y2 averaged, okay? And then 3 plus negative 5 gives me negative 2. When I divide negative 2 by 2, that's negative 1. And negative 3 plus 1 is also negative 2, which again, when I divide by 2, is negative 1. So that gives me a midpoint of negative 1, negative 1. All right, so there we go. That is a bunch of examples. Again, if you need any clarification, just text me on our chat thing. Okay. The last thing that we're going to look at is degree. So you may recall, again, in theory, I don't really know how your last year went, that the degree, oh shoot, sorry guys, there we go, that the degree relates to the exponents in a polynomial, right? So last year, I hope that you talked about how a degree of 0 is a constant, a degree of 1 is a linear function, a degree of 2 and 3 and 4 and so on would be talked about in future years. So a degree is always talking about looking at the exponent in in the polynomial that we're looking at. So again, a reminder also on polynomials before I fill in these blanks that this is a polynomial, this is a polynomial, this is a polynomial. Any of these things are polynomials, right? Because they're a combination of terms, and it's an expression or equation with a combination of terms. And so that is what we're looking at there. Okay, sorry guys, my stylus just turned itself off. That's really fun. Oh my goodness. Okay, so we're gonna just fill in these blanks here. So degree is always the value of the, let's use this fun color, highest power. Okay, in a polynomial. In a linear relation, the degree is 1. The degree of it is 1, and the degree of all variable terms is also 1. Okay, I think I made a typo here. That's why I just paused. That doesn't make sense. What I'm trying to say is that in a linear relation, the degree is 1. Okay, so you can just cross off that of. That's not supposed to be there. And the degree of all the variable terms is 1. And the reason for that is because, again, remember that because the degree is the highest power in a polynomial, then we couldn't have a polynomial term with a degree or variable. Oh my goodness, an exponent higher than 1. Okay, so highest power has to be 1. Therefore, all variables in a linear relation will have a degree of 1, or an exponent of 1. Okay, so let's look at the degree of these polynomials. So here we have y equals 2x plus 3. Remember, there's a little invisible 1 exponent up there, so that means this has a degree of 1. And then if you take a look at the second thing here, second equation that I gave you, then we have a few terms with variables in it, right? So we have this one that has x squared, and then this one that, again, has that little invisible 1. So we're just going to compare all of the terms that have variables in it and figure out which is the highest power. So in this case, I hope that it's very clear to you that that 2 is the highest. So this has a degree of 2. Okay, that equation has a degree of 2. All right. Again, a reminder that linear relations always have a degree of 1. Okay, so when we look at a question like this where it says state whether each equation represents a linear relation, then we are looking for linear relations that have a degree of 1, so any equation with a degree of 1. So here, y equals 2x plus 3, there's that little invisible 1, so that means that the highest power here is 1, and that means that this is a linear relation with this terrible stylus. So fun. Moving over across to y equals negative 5x plus 9. Again, there's that little invisible 1 on that exponent. I'm going to make that a little bit better. There we go. So again, that's the highest power in the equation. My goodness, you guys, look, I didn't sleep last night. I'm trying to be clear, but it's hard. This makes it also a linear relation. All right, moving down to f is equal to 1.8c plus 32. Fun fact, this formula is how you figure out what the temperature is in Fahrenheit if you have the Celsius temperature. So you could use that in your life if you want. All right, so it doesn't matter what the variables are, okay? So if we have a variable that has a degree of 1, like this one, that is so messy, oh my goodness, there we go, then we know that's the highest degree, highest exponent, right? Though there's nothing higher than 1, so then that does make this a linear relation as well. Promise we are going to look at some non-linear relations on the next page. Okay, and then same thing with d equals 100 times t. We see that little exponent of 1 on t. It's a secret, and you don't have to write it if you don't want to, but it does make this also a linear relation. Okay, here we're going to see that, whoops, there we go. Oh gosh. There we go. That we have a little exponent of 1 on this t, and then actually an exponent of 2 here. And so because of that, then this is not a linear relation because there is an exponent of 2 on t. Okay, let's do the next one. Y equals square root x. Now, using the mirror, I know that square root is equal to an exponent of 1/2. And so then when I take a look at that, is that exactly a degree of 1? No, it is not. And so because of that, this is not a linear relation, because the degree is 1/2, which is not exactly equal to 1. I'm going to make that a little bit neater. Okay, here we can